Okay, we're going to solve this trig equation that deals with double angles by taking a look at, first of all, the trig function, which is cosine, and then we're going to look at the double angle. We actually have two double angles, 4x and 2x. We can use the double angle identity to change or transform cosine of 4x into terms of an angle with only 2x. And that would entail taking the double angle formula, cosine of 2a is equal to 2 cosine squared of a minus 1. Now this works because 2a is a double angle in terms of a. If I have 4a, that means my double angle is in terms of 2a. And that's exactly what I want to get, is I want to get this in terms of 2x. So I'm going to take the cosine of 4x, and it is going to become 2 times cosine squared of 2x minus 1. And that is equal to the cosine of 2x. Now I'm going to have an equation that's quadratic in nature. 2 cosine squared, there's my squared term. I'm going to subtract cosine of 2x from both sides. So I'll have minus cosine of 2x, that's my linear term, minus 1, which is the constant term. And now I can factor this trinomial. 2 cosine of 2x and cosine of 2x equals 0, so that I can use the zero product property. I want the outer and the inner terms to add to be negative 1. So I'll have 2 cosine of 2x plus 1 times the cosine of 2x minus 1, so that the outer and the inner end up combining to get negative cosine of 2x. Now we're going to take each factor, 2 cosine of 2x plus 1, and the other is cosine of 2x minus 1, and we'll solve each of those. So I've got 2 cosine of 2x plus 1 equals 0. The cosine of 2x minus 1 equals 0. Oh, sorry for that. Let's scroll down here. Try to scroll down, extend the page a little bit. The cosine of 2x equals negative 1/2, and the cosine of 2x equals positive 1. Now the cosine of 2x equals negative 1/2 will happen at 2 pi over 3 and every 2n pi. It will also happen at 4 pi over 3 and every 2n pi. While the cosine of 2x equals 1, the cosine is going to equal 1 when 2x is equal to 0 plus 2n pi. Now I'm going to divide each term by 2, or multiply each term by 1/2. This first one will become x equals pi over 3, plus, when I multiply by 1/2, I will end up with n pi, but giving myself a common denominator, I'll make it 3n pi over 3. Same thing here, when I multiply through by 1/2, x will equal 2 pi over 3. When I multiply 2n pi by 1/2, I end up with just n pi, but I want a common denominator, so I will make that 3n pi over 3. And then this last one, x is simply going to be 0 plus n pi. When I take everything and divide it by 2, that's the n pi. Now I did the same thing here. I multiplied by 1/2, multiplied by 1/2. And when I multiply this 2n pi by 1/2, I get just n pi, but I needed a common denominator, so that's how that became 3n pi over 3. And now we'll just solve. Pi over 3, let's see, when I put a 0 in for n, I get pi over 3. When I put a 1 in for n, I'll have 4 pi over 3. And if I put a 2 in for n, I will get 7 pi over 3, which exceeds 2 pi. So we're done with that one. The next one, 2 pi over 3. When I put a 1 in for n, I will get 5 pi over 3. And if I put a 2 in for n, I'll again exceed 2 pi. It'll end up being 8 pi over 3, which is over 2 pi. And x equals 0, n pi. When n is 0, x is 0. And when n is 1, I get pi. When n is 2, I get 2 pi, but the interval is from 0 to 2 pi, and 2 pi is in parentheses. Therefore, 2 pi cannot be included. And that is how we get all 6 answers.